So the special centers are kind of like what we're talking about here, okay, of a triangle. Okay. So we're going to learn a new special center today, but I first want to review the one we did yesterday just so we have it down, okay? So let's again draw a triangle. You can draw your triangle however you want. I'm going to try and draw a right triangle here and see if our conjecture was true about whether our circumcenter will end up being on our hypotenuse like we thought. And again, I'm kind of like eyeballing the right angle there.
We don't have to draw right.
You can draw whatever kind of triangle you like. Okay. So I drew roughly a right triangle there. Okay, you can name the triangle however you want. I'm going to name it DEF. Okay, now.
Is it okay if we put a box on it?
Yeah, if you want to.
Could it be a circle?
There will be a circle. Okay, now. Oh shoot, what did I want to say here? Oh, if you have trouble with your paper sliding around on you when you're doing your construction, if you want to get your books out, and if you put this paper kind of inside your book, just wherever, it'll not slide around as much. So I'm going to open my book up just to a random page and just put it in my book like this, so that way it's easier to do your constructions this way. True, but it also slides around some too if you're using a compass. So it's up to you though. Okay. So again, we're going to find the circumcenter here. Okay, and what special segments do we draw to find the circumcenter? Perpendicular bisectors. So found using perpendicular bisectors. Okay, and what's the shortcut? What do we call that kind of construction? What's the nickname we gave it? Football construction. So in parentheses, I'm going to put football construction.
Did you really put quotation marks?
Yeah, because it's a nickname, so it's not the... Okay. All right. So found using the perpendicular bisectors. So let's go ahead and do that. Pick a side. I'm going to pick my side here, FE. Let's go ahead and do one perpendicular bisector. Okay. Make sure your compass is open more than halfway. And then just do your two arcs there. Okay. Again, because sometimes it can get overwhelming to have, so many arcs on here, I'm going to erase away some of my arc, just so that way I have my intersection points and it's less confusing for me. Okay. Don't erase away everything, obviously. We need to show our work. Circumcenter. Special centers of a triangle. All right, and then we'll draw that perpendicular bisector.
My point's going to be a little off.
And that's okay. That happens sometimes.
It's fine.
Well, good thing Matt's not the teacher. Okay?
I think we should
No, I have not yet.
I'm about to run mine.
Yeah.
How many students you have?
Let me see here. I've got 27 plus 20, so 47.
47.
So if you want to just make 50, just in case. Thank you. Remember, you can have it do stapling too, Mr. Booth. Okay.
I always forget to start my
So there's that. Again, I'm going to, just so we remember, right, that creates a right angle there, and then these two parts are going to be congruent. I'm going to mark that in, just so we remember that. It's also an important property. Okay? And then we're going to turn our paper and do another perpendicular bisector. So I'm going to pick side FD here, DS. Okay. I can see my compass is not quite more than halfway, so I'm going to open up a little bit more and do the arc. And then do the arc here. Okay, and again, if you want, you can erase back some of the markings. And then again, we'll draw that perpendicular bisector in. And what do you know? There's my right angle, there's my right triangle, and it looks like my circumcenter is going to be basically right on the hypotenuse there. So it looks like our conjecture, it might be right.
Why didn't we write this in the notebook?
In our notebook? What do you mean in the notebook? In the book, because the book doesn't have space to do this. That's why. Which I think is really silly.
I know, that's hard to write in.
Wait.
Yeah, they're hard to write in.
Okay, the book actually does not give us space to do this, unfortunately. So we're going to do it on our own. Okay, again, this is a perpendicular bisector, so this is a right angle here, and this side is congruent to that side. Excuse me.
And then draw your little point.
And then, yep, if you want to highlight your little point there, we can label that. So there's the circumcenter right there.
It's okay if you did it on different sides than you did. Like
I'm
if
so-
you did it on like that side.
If you did a different side, that's fine. I'm glad you think so. Good. We're going to do the Incenter. We're going to do a new center today, too. I just wanted to have this as well. Just a new one special center today. Yeah. So, point to your compass. Let's actually show that it's a circumcenter. So we're going to put the point of a compass on the circumcenter, and then I have to open my compass up to what? To one of the vertices.
I drew my word.
Oh, I thought it was a point.
Well, that's the same. It is a point, but it's a vertice officially. It's the point of the triangle, so it's a vertex or a vertice. Okay. So we open it up to point F there. I'm going to do F. Again, let's do our circle. Okay, it looks like I didn't do too bad of a job there. I think I hit D, E, and F. And I'll call this point C, I guess, for the circumcenter.
I thought we called it P.
You can call it P. I'm calling C just this time.
Can we call it like any letter? That's not the other letter?
Yeah. Okay, now, very important here. The distance, CD, equals, what else? CE equals CF, okay? Very important here. C to D is equal to C to E is equal to C to F. It is equidistant from the vertices, okay? So you can kind of imagine here, for example, if you had like a map, and you had 3 towns on the map, and those towns didn't have, for example, a fire station, right? Didn't have like a place for fire trucks and stuff like that. If you wanted to find a place so that the fire station was equal distance from those 3 towns, you would draw a triangle between the 3 towns, and then you would find the circumcenter, and that point would be the same distance to each of the 3 towns. Now, obviously, you'd have roads to deal with and stuff like that, but it would still give you an idea about it being how, equal distance to those 3 points. Okay? So that's a very useful application, I would say, of that thing. All right? Questions on circumcenter? Questions on circumcenter? All right, then let's move on to the next special center, and this one is called the incenter. Okay? The incenter. Now, the circumcenter resulted in a circle that went around the outside of the triangle. The incenter is going to result in a circle that does what? Fits inside the triangle. Fits inside the triangle. Okay? So this is found using the angle bisectors.
What's an angle bisector?
Okay? The angle bisectors. We don't have a nickname for this construction. We don't have a nickname for it. Okay? We don't have a nickname for it. So let's draw a triangle here.
Another one just like you did.
I'm going to draw a acute triangle here.
Can you do this with any shape or just triangle?
So, great question. You, I don't know the answer to that, actually. Like, if you can find the incenter for other shapes, you mean? I'm not sure about that. For a square, I believe you can, but I'm not sure about, like, a rectangle, for example. I don't know. I have to think about that. I'll have to think about that. Or for a rhombus, I'm not sure. Or even, like, a pentagon or a hexagon, I don't know. I'll have to think about that. Okay? Okay, so here's my triangle. I'll call this triangle, let's see, I'm DEF, so GHI. Okay, so angle bisectors. Let's remember here. Anytime we do some sort of angle construction, the point of my compass always starts on a vertex. So I'm always going to start, for example, I'm going to bisect angle I first here.
But you could start with angle H or angle
You could start with angle H or angle G. I'm going to start with angle I, though, because here's why. Angle I, since I'm going to use my compass with my left hand here, okay, I want the angle that I'm going to use to be on my left. If you want to do angle H, I recommend you turn your paper so that angle H is, on your side there, okay? You want it to be kind of facing you as well. So anyway, you put your pointer compass on angle I, and remember we swipe and we hit both sides of that angle. So IH and IG.
Is this like halfway or what?
This one doesn't matter. So again, just swipe so you hit both sides of that angle. It's not ratchet, this is how you do it. Okay, so again, just swipe both sides of your angle, and then if you want, you can open your compass up or close it some, but you don't have to. Now that we've done that, we've created this point and this point.
So do we only have to do this for 2 angles?
Only for triangles, that's right. And then once you found those points, you just put your compass point on those 2 points and swipe as well.
Wait, why are you swiping there?
Because again, that was where my arc intersected the side.
So just
And then you do the same thing for the other point where the arcs intersect, my first arc intersected the side, swipe in, and then that creates an intersection. And you can erase these back. So once more, we have our swipe from I, like that, and then that creates these 2 points, and then you swipe from those 2 points in, and swipe from that one into the intersect.
then you draw
So swipe, and then there you go, Zarya, perfect. Exactly, that's your intersection. So that's the point. We're going to draw from I through this point right here.
Mr. Wood, this thing is bugging me.
It's moving around on you? It's on your book too, though? Okay.
I'm drawing an arrow.
We're going to draw through I
No, this is gonna get confusing.
like so. You're right, if you feel it's going to get confusing, you can feel free to erase back some of your arcs.
Can we do it again? Because you was kind of fast.
Yep, we'll do it again. I'm sorry. I'll do it again. We'll do it again.
So I can erase every single one but the
Yeah, don't erase like the arc here, or those little crisscrosses too.
Can I just leave the dot?
I guess so, but make sure you leave the crisscrosses right there though. Okay, so there's one of them. Now pick another angle. I'm going to do angle H. So I'm going to turn my paper here so that angle H is to my left. Excuse me.
Are you doing it again?
We're going to do another one. We have to do another one. Yeah.
I'll do it.
I don't.
Okay, so we'll do another one here. So Jane, did you label yours the same way I did?
What did GIH?
Okay, so that's fine. So I'm going to do angle H here. Notice where I turned my paper so that angle H is like kind of facing me, but it's on the left-hand side here. This makes it a little bit easier because I like to readjust things. Again, compass point on H.
Can you make it smaller? Or
You can adjust your compass size if you want to. I'm going to make mine a little bit smaller because it looked like it was going to interfere with some of these other markings here. I'm going to make the arc. Okay, so it creates these 2 points now.
Can we just make it bigger?
If you want to make it bigger, that's fine too.
No.
Okay? So then I did that single arc,
Can you
touching both sides.
1 second?
Shh. Guys, Derek, Jason, shh. Jason, you should have your compass in your hand right now doing constructions. You should not be sitting there with, scratching yourself, okay?
Wait, what side do I put it on?
pick one of the other angles and start bisecting that angle. You do one arc. Okay? Ramel, you too, buddy. You should be working right now. I don't know what you're doing. Compass in your hand. Let's get constructing here, okay? You're fixing your chair. Yeah, very important. I understand. But you also need to be doing constructions because this is geometry class, not chair fixing class. Beautiful. Looks good. Okay? So now, once you've done that, Jaden, we're good now? You did your arc?
I have a question.
I understand. There's a lot of lines. 1 second, Matt. Hang on.
I have the first line where it's like.
Have the first arc here?
Yeah.
Okay.
No,
Yeah.
that's the other one.
Okay. Let me get Matt real quick. Yes, Matt.
So is an end result is just being split such as all three intersections?
Yes. Yes.
Okay.
Yes.
Is this going to be on the crest that we have to...
It could be, yes. Yes.
So,
Derek and Jason, gentlemen, stop talking. Thank you.
So I made my arcs bigger because I can't do really
Dominic, you
small
too. Listen up,
arcs.
please.
I can't do really small arcs for this because it's like impossible.
I understand, so do it bigger if you need
So
to.
I made mine big, and so
Mhm.
do I put it on that one of the point and
Yep.
then
Word.
swipe against GI?
You swipe again, so that you, when you do your first swipe here, everybody, okay, you do that first swipe. At this point now, you can open up your compass more if you want to, and you can swipe it, you know, way out here if you need to. As long as those two arcs intersect then, so there's where mine two arcs intersect, right there, okay? And now you just want to draw from H through that second, through that point of intersection there, the two arcs, okay? And then that creates my angle bisector, okay? And you'll notice now my two angle bisectors intersect at a point, specifically this point right here. Okay, I'm going to actually mark these. If they're angle bisectors, I can mark these two angles as being congruent as well. Okay, so there it is. This is not the only one we'll be doing, so if you're still having trouble with it, that's okay. We can come back to that and fix it here later in class too.
Do we have to make this angle one?
You don't have to, but I'm doing it just so you guys can see that they are going to be congruent angles. They should be.
Oh, this is easy, I already got it.
Okay, good, Jason. Thank you. All right, so now that we have this point, this is the incenter. Okay. Thank you. And then we're going to put the point of our compass on the incenter, and since this point is equidistant to the sides, I'm going to close my compass
Turn on I.
so that it barely touches one of the sides. So not I is a vertex. I want to do it so that it barely touches one of the sides. So here it's barely touching side
Why can't it touch it?
IG. Barely touching it. Just touch it,
Why
but
can't
barely.
it touch it?
Okay, and so then you turn your compass, and this is harder because it's a smaller circle, but then you can spin your compass or your paper, whatever's easiest for you. Oop, and my compass is moving all around on me here. Okay, if you turn your, actually I'm going to just turn my paper, it kind of does stay still.
It's going way too fast.
Okay? All you do is you do the circle right there.
Can you repeat the circle part? You lost it.
So again, real quick here,
That makes no sense.
point of the compass on the incenter. The incenter is equidistant from the sides, so you open your compass up so that it just barely touches one of the sides of your triangle, and then you do your circle. Okay, using your compass.
Why barely touch? That's,
What do you think it should be, Ikeba, if not barely touch?
why can't it just touch it? Like, why?
That's what I'm saying. Barely touch it. So that's touching it.
Can we do another one?
We will, yes.
My compass is, mine's not.
It's not, it's too small.
It's like...
Oh, it's too loose. Yeah, I understand. Yeah, we gotta get some better compasses. And I could use a screwdriver on that, but I don't have my screwdriver with me, so. But anyway, that's the idea, okay? So, in this case, okay, and so I'll call this incenter, we'll call it, I don't know, point I. Oh, no, I already called it I, can't call that. So I'll call this, I don't know, M for the incenter there. That's fine. Okay? The incenter is equidistant, okay, to the sides of the triangle. Okay, the incenter is equidistant to the sides of the triangle, which is shown here by the fact that the circle fits inside the triangle and the circle touches each one of the sides, or should about touch each one of the sides. Okay, again, if it's not exact, it's because, you know, our compasses, maybe our compass work isn't that accurate. Okay, so incenter, equidistant to the sides, it touches all the sides. Circumcenter, equidistant to the vertices, or the points. Okay, so there it is. You gave a question.
You know how, like, in the first problem, the circumcenter, like, the circle doesn't, it's supposed to touch all the points, but it doesn't exactly touch all the points?
Right, and again, that's our own
So,
error, yes, but it should.
In the incenter, is it okay that, like, my circle, like, didn't exactly touch all the points?
Yes, in the
and
same-
a little bit, like, went out of the
Yes,
triangle?
in the same way, if we make a little bit of errors here, it's not going to be exact. Same deal here. That's why it's important for you to leave your compass markings on there so I can see that you did it correctly at least, okay? Because the circle won't always fit exactly because, again, we're humans, we're not perfect, and these compasses aren't perfect either, right? Some of us really know their compasses aren't perfect, okay? That's it. We're going to do one more special center tomorrow, but right now, that's where we're going to leave it. So we'll stop with that, but I would like you to open up your books then. We're going to go into those.
So are we just
Okay.
practicing now?
So we're going to go to page 3. Let's go to an actual problem. So 373, we'll do another one here just for some practice.
So what are we doing after?
Wait, Mr. turn this in.
We'll look at some problems and then we'll get to the homework and stuff like that. We shouldn't take that long.
Is the homework, do it?
Later.
Is the book the homework?
Yeah. You don't like that? Why not?
I just don't like the paper.
I agree. It's kind of crummy, but that's what we got. All right, page 373. 373, please.
It doesn't look like a problem.
Okay.
Are we doing that big triangle?
You got it. Okay, so, page 373, please. Page 373. We're jumping around a little bit. This is just the way it is. The book is not written in the same order that that we teach it in. That's all. Well, it's on this book. Remember, there's other ones we have too. So, yeah. Okay. So, the directions here. Okay, ask us to use a compass and straight edge to construct the inscribed circle of triangle PQR. So inscribed, okay, like, so what does that word mean, right? Well, in means inside, and scribe, right, means kind of like write, right? When you scribe something, it's to write. So we're going to write a circle inside of our triangle there. Thank you, and thank you, Mr. Leininger. Okay. We're on page 373. So, all right. So, yeah. So, Derek, you're just going to go back to your seat. Brianna's going to sit where she normally sits. Okay, and we'll figure something out from here. So, we're going to inscribe this. So, again, let's take a look here. Let's pick an angle. I'm going to pick angle P because it's right there. Okay, so angle P, I'm going to take my compass, and where should I put the point of my compass? On point P. Okay, so on point P. And so, guys, this is for all of us that are having difficulty. Make sure you follow along with this because this is, one more chance here to get practice. And if I go too fast, please say something. In the center. Okay, so if you're having trouble, then follow along with me, please, right now, okay? We're, again, going to start on point P. And then what do?
Oh, you do side to side.
A big arc that hits both sides. And by a big arc, I mean just, an arc that hits both sides of my triangle there. So there it is. Okay, so go ahead and do that real quick. Point P, big arc that hits both sides of the triangle. Okay, that creates a point right there and a point right there. Creates 2 points that are the same distance to P. Right, this point is equidistant to this point from P. This distance is the same as this distance. Okay. So there's our first arc. Does anyone not have that arc done yet? All right, we're ready to move on to the next step. All right, next step. Now we're going to take our compass, and these 2 new points we created, our compass point goes on that. And we swipe. and then compass point on the other point, and you swipe. Sorry?
Did you just draw the points where you want?
No, these 2 points I came up with from the arc. The arc I drew first, and then that point and that point I made up from the arc.
Doesn't matter how far you open it.
Nope, as long as these 2 arcs intersect, Jaden, your compass is open far enough. Okay, and then straight edge. Oh, sorry, I'll wait. I think not people.
Yeah.
You ready to move on? So then straight edge from P through the 2 arcs there, where they intersect, where they crisscross. Okay, just like that. Okay, questions? Jaden, question, what?
How far to open it?
For when I put my compass point here, how far to open it? You can leave it the same length you had it from point P. It should still work. If not, you can...
What if it goes out?
That's okay. That's okay. As long as they intersect, that's all that matters. This one right here, you take your compass point, you put it on this point right here, where they intersect to the side, and then you just do 1 arc into the inside of the triangle. Yep, just like that. Perfect. And then do another one just like it from the other point, and it should intersect those 2. Good. And then you draw from P through that intersection point where it crisscrosses. Okay? There's our first angle bisector. If you want, you can mark the little arc congruences there to show that those 2 little angles are going to be congruent, right? Because we know it's an angle bisector. All right, let's pick another angle here. What's another angle we want to do? R? Okay, I heard R. So I'm going to turn my paper so that R is out of the picture. Sorry. I'm going to turn my paper so that R is right here, okay, on my left, the normal kind of place where I do my angles. That's comfortable for me. I'm going to adjust my compass some here. And then I'm going to intersect both sides of the angle again. Okay, creating this point and this point. Okay? So, yep, we just do the same thing, and then Jaden, exactly right. Do the same thing over again to another angle. So I did 1 big arc to intersect both sides of angle R. And then for this one, I'm going to open my compass up wider, so that way I'm not like interfering with these other arcs here. So you see how big how wide my compass is now. That's okay. I can still do a big arc right here.
What if it touches the other one?
That's okay if you're okay. Like just if it's okay if it's touching it. Just don't get confused. That's all. Just don't get confused. And so there's my little crisscross again. Okay, because I open my compass up a little bit wider, and then from R through that point. Okay, and then there is my incenter. Finally. Okay.
And it doesn't matter what segment.
It doesn't matter which angles you bisect. Any pair of angle bisectors should intersect all at the same point. Okay. If we went ahead and did the angle bisector for Q, it should intersect that same spot. Of course, again, understanding EKVA that we're not perfect with our compasses, it might be a little bit off, but it should be roughly that spot. And just to prove it, what kind of circle can we draw here?
Circle.
That fits where? Inside. So a compass point on the incenter, and then close your compass so that it just barely touches one of the sides. Okay, see mine went kind of...
Wait. So with my points, when I go to the line, they cross where the other one was. Where those 2 lines are not.
Right here?
Yeah, those 2 lines are there.
Yep.
Mine cross right there.
That's where they should. The angle bisector should cross right there.
No,
Oh, these little arcs?
Yeah.
That's okay, as long as like your angle bisectors intersect there. That's what's most important. Okay. Sometimes, yes, your arcs will kind of overlap like that, and then I'll mark those 2 things right there. Okay. So there it is. So remember, again, this point here, and I'll call this one N, This is equidistant to the sides. So if I measured from end to the side, from end to the side here, from end to the side there, it would all be the same distance. Okay?
Mr. Wood,
Yes.
look, I'm in my own direction.
Very good. That helps. If that will help you, absolutely do that. Okay? All right. So, any questions on constructing an incenter? I want to go through one other thing here, and it's just like looking at some problems, basically. Okay? Using some math, using the properties of the incenter.
You have to draw two of them.
You need to draw two angle bisectors, yes. You need to, because if you only have one, you're not sure what the point, the point will be somewhere along this, but you have to draw another one to show where the intersection point is the incenter. So that's why you need two. You could draw three if you wanted to, and but it would go to the same spot. So that's why you only need two.
So say if I drew one on the test, will I get half credit for it?
You wouldn't get full credit. So yeah, you definitely want to draw all of them. Okay.
Mr. Wade, my circle came out.
And that happens. I'll come take a look at it, Jaden, later. Right now, let's finish. Let's go back here to page 372. Okay. So it's kind of weird for me to say that the distance to a side, right? When I talked about the incenter here, I said that the distance from my incenter to a side, okay, is the same as the distance from end to this side, is the same as the distance from end to this side. But here's the thing, right? If you talk about distance to a side, that can be a little bit confusing because... I'll wait. Okay. When I say distance to a side here, Ramel.
Shut up.
No, Ramel, when I'm talking, he's not, okay? When you can say it in your head, Ramel, and then it's a lot easier because we're really talking to anyone anyway, okay? The distance from end to a side. Here's the problem with that. From end to a side, well, I could say end to like this point on the side or end to like this point on the side. Like, how can I actually find the distance to a side? And that's how what we do to find a distance to a side. The distance from a point to a line is the length of the perpendicular segment from the point to the line. Okay? So for example here, the distance from C to PA is this perpendicular distance. Okay? It's not just any random like length to the side. It's the perpendicular length from A to C there. Same thing here. The distance from point C to ray PB here is this perpendicular distance. Okay? So if you have an angle bisector, notice here that ray PC is an angle bisector. It is, any point on this angle bisector is equidistant from this side or this side, the two sides of the angle. So any point on an angle bisector is equidistant from the two sides of that angle. Okay? So since angle, it says over here, I can't listen to that. So APC is congruent to BPC, thus PC is an angle bisector. So therefore AC will be the same as BC. Okay? That also works in reverse. If you have a point that's equidistant from two sides, okay, like this, that means this thing is an angle bisector. These two angles must be congruent. Okay? So let's look at that as in practice here. So for example, here's a picture. Okay? Very clearly in this picture, LKM is congruent to K or MKL, right? You can see the little angle markings there. They're teeny, but you can see that they are going to be congruent. So therefore, if JM has a length of 12.8, what must be the length of LM? 12.8 as well. Yeah, it's got to be. Okay, so the answer here is 12.8. Okay, that's that length. Okay, so it's equidistant. This M, since M is on an angle bisector here, then 12.8 and 12.8, they have to be the same distance from the different sides. Okay, looking at B. Okay, here we can see that point D is equidistant from the two sides of this big angle. Exactly, so BD is an angle bisector. Therefore, if angle ABC is 112 degrees, so if this full angle here is 112 degrees, what is the measure of angle ABD?
Oh, you divide by half.
Yeah, 112 divided by 2.
I don't know if that is.
So that is 56 degrees. Okay, 112. So point D, since it's equidistant from the two sides here, right? D is the same distance from AB as it is from BC. They're both 74. So therefore, this thing must be an angle bisector. So if the full angle is 112, to To find ABD, like Jason said,
Like, I
half
get
of it.
But where does it ask me to do that?
It says find the measure of angle ABD given that measure of angle ABC is 112. So that's what we're trying to find,
Oh,
ABD.
okay.
The 74 is there, Haley, to show that this point D is the same distance from this side of the big angle to this side of the big angle. The distance from D to this side is 74. The distance from point D to this side is also 74. So that's showing that they're equidistant. Therefore, this thing is an angle bisector.
If it's like 112 together.
The degrees.
56.
So then, yes.
Oh, you mean like 74 is the length?
Yes, yes.
Oh.
74 is the length from A to D. D to C is 74 in length. Notice there's no degree symbol there. That's the giveaway. Okay, so let's look at some of these here together. Let's look at these last two, and then I'll get you guys started on your assignment. Okay, so let's look at number 4 at the top of your turn. Good, I'm glad you think so. Okay, so number 4 says find each measure. We want to find QS. So here's QS, and exactly right, it's 14.7. Right, but be careful, this thing also has to be an angle bisector, but it is. See how the two angles are congruent there? So if these two angles are congruent, this is an angle bisector, and if that's 14.7, that must also be 14.7. Okay, point S is equidistant to the two sides. Okay, questions on any of that? Hopefully that's pretty straightforward.
What if we get a decimal?
It's possible. Let's take a look here, number 5. Okay, so number 5 says find the measure of angle LJM. So LJM, that means we want to find the big angle right here. KJM is 29 degrees.
Oh, so you do 180 minus.
Wouldn't you do 29 divided by 2?
So let's take a look here. You got it right there, Skylar, though. So this point K is equidistant to the two sides, right? It's 62 to this side, it's 62 to this side. So that means this angle is being bisected by ray JK. If MJK is 29 degrees, what must LJK be?
Oh, it's 29.
It's also 29.
Oh, I knew.
And so therefore, the big angle MJL, or LJM, sorry, is what? Or how will we find it?
58.
It's 58, 29 plus 29. So I'm going to go ahead and write that. 29 plus 29 is 58 degrees. So that's the answer. Okay? So that's the use of the angle bisectors, okay? That's how we can use angle bisectors, kind of solve some stuff there. Okay? Questions on any of that? Yes, so your assignment then, if you would please, excuse me, yes,
An inscribed circle, is that the Incenter thing we did?
yes,
Okay.
yes. Okay, so on page 375, and I'll write this up on the board.